Hi friends, let us today start the third session on time and work. Now let us start with the first question. A and B can do a piece of work in 30 days. B and C can do the same work in 24 days. C and A can do the same work in 20 days. All start the work together, but after 10 days, B and C quit. Further, how many days will A alone take to complete the remaining work? Now, the best way to solve this problem is by using the LCM method, that is chocolates. Now, let us start the solution for this problem in a simple way. Now, the given information is that A and B together can complete the work in 30 days. B and C together can complete the same work in 24 days. C and A together can complete the same work in 20 days. Now first let us try to find out the LCM of 30, 24 and 20. 30, 24 and 20. Now I can take out 5 common, 5 6, 5 4s. We can take out 2 common, 2 3s, 2 12s, 2 2s. Again I can take out 3 common, 3 1s, 3 4s, 2. Again 2 common. So if you multiply all this, 5 into 2, 10, 30, 60, 120. So the LCM of these three numbers is 120. So let us assume the total work is to eat 120 chocolates. Now A and B together will eat 120 chocolates in 30 days. That is, A and B together in a day will eat 4 chocolates. B and C together will complete the work in 24 days. That is, they eat 120 chocolates in 24 days. Now together in a day will be eating 5 chocolates, which is 120 by 24. Now C and A together can complete the same work in 20 days. So per day they will be eating 6 chocolates. That is 120 by 20, 6 chocolates. Now all the three together will eat how many chocolates in a day? Now if I add all these three, obviously I should get 2 times of A, B and C, which is 15. So A, B and C together in a day will be eating 7.5 chocolate, and A alone should be eating 2.5 chocolate in a day, because we know that B and C in a day will be eating 5 chocolates, A, B and C in a day will be eating 7.5 chocolates. So A should be eating 2.5 chocolates. Now start the solution. Now solving the problem is very simple. Once you get these numbers, solving problem becomes very easy. Now the total work here is to eat 120 chocolates. Now in the question it is given all the three started the work together, but after 10 days B and C quit. So if you analyze this problem, we will come to know that B and C together worked for 10 days. Of course along with A, but let us take the information about only B and C. Now B and C together in a day will eat 5 chocolates. In 10 days, how many chocolates will they eat? Obviously it should be 5 into 10, 50 chocolates. Now B and C in that 10 days have eaten only 50 chocolates. Now the work has to be completed. The total work is to eat 120 chocolates. Now who should eat the remaining 70 chocolates, or who ate those 70 chocolates? Those 70 chocolates are obviously eaten by A. A, to eat this 70 chocolates, he will take how many days? A per day will eat 2.5 chocolates. To eat 70 chocolates, he takes 70 by 2.5, which is 28 days. So A worked totally for 28 days, or we can say the total work is completed in 28 days. But the question is not that. The question is, after B and C quit, how many days did A take to complete the remaining work? So the answer for this question should be 28 minus 10. 18 days. So, after B and C quit, A alone took 18 days to complete the remaining work. Now, let us go to the next question in this chapter. A started work and left after 8 days, and then B completed the remaining work in 14 days. Had A worked for 9 days, then B would have completed the remaining work in 12 days. In how many days will the work be completed if A and B work together? Now, let us try to analyze this question first and then solve the problem. Now, in the question it is given that A started the work and left after working for 8 days. Now, first of all, we do not know the efficiency of A. So, definitely we cannot tell how much work did A do in that 8 days. But we know that he worked for 8 days and he left. And then B completed the remaining work in 14 days. And we also do not know the efficiency about B. So, we do not know how much work did B do in that 14 days. But if the work has to be completed, A should work for initially 8 days and then B should work for 14 days, the work will be completed. Now, let us write down this. A works for 8 days and he quits, and then B completes the remaining work in 14 days. Now, let us see the next statement. The next statement is had A worked for 9 days. Now, here A is working for only 8 days. If suppose A works for 9 days, that is 1 day more, then B would have completed the remaining work in 12 days. So, A instead of working for 8 days, if he works for 9 days, then B will take 12 days to complete the remaining work. Now, let us write down this also. A, if he works for 9 days, then B will complete the remaining work in 12 days. Now, if you analyze, this problem is very simple. A is working for 8 days and then B is working for 14 days. Here A is working for 9 days and then B is working only for 12 days. Now, why did B decrease his number of working days by 2? Here he was working for 14 days, here he is working only for 12 days. Why? Simple reason, because A is working for 1 day more. So, what is A doing in this 1 day? Definitely A is doing 2 days work of B. Whatever the work A does in 1 day, to do the same work B should take 2 days. So, who is more efficient? Definitely A. A is how much more efficient than B? A is twice as efficient as B, because 2 days work of B is done by A in 1 day. So, when I say A is twice as efficient as B, once again I solve this problem by chocolates. If A is twice as efficient as B, and if B eats 1 chocolate per day, A should be eating 2 chocolates per day. Now, we know that if the work has to be completed, A should work for 8 days and then B should work for 14 days. Now, in 8 days, how many chocolates will A eat? Per day, we took that A will eat 2 chocolates. In 8 days, he will be eating 2 into 8, 16 chocolates. And then B will complete the remaining work in 14 days. Now, B per day will eat 1 chocolate. In 14 days, he should be eating 14 chocolates. So, the total work here is 16 plus 14, 30 chocolates. Now, this 30 chocolates is the total work which should be now completed by A and B together. A and B together in a day will be eating 2 plus 1, 3 chocolates. Then to eat 30 chocolates, how many days will they take? So, time taken by both A and B together to complete the work should be 30 by 2 plus 1, that is 3. 30 by 3, answer is 10 days. So, A and B together will complete the work in 10 days. Now, let us discuss the next problem in this chapter. A can complete a work in 15 days and B can complete the same work in 20 days. In how many days will the work be completed if A and B work on alternate days and A starts the work? Now, in this particular problem, both A and B are not working together. They are working on alternate days. In how many days will the work be completed? Now, the best way to answer this question is once again the LCM method. A can complete the work in 15 days and B can complete the same work in 20 days. Now, the LCM of 15 and 20, 5 3s, 5 4s, 5 3s are 15, 15 4s are 60. So, I assume the total work is to eat 60 chocolates. So, A will complete 60 chocolates in 15 days. So, per day A should be eating 4 chocolates and B will complete 60 chocolates in 20 days. So, B per day should be eating 3 chocolates. Now, here the problem is both A and B are not working together. They are working on alternate days. Now, who is starting the work? Now, according to the problem, A starts the work. So, definitely the work should be going on like this. First day A works, second day B works. Again third day A works, fourth day B works and so on. So, if you clearly see the work done after every 2 days will be same. Now, let us solve the problem. Now, our problem is to eat totally 60 chocolates. After one day, how many chocolates will be completed? Now, on the first day A is working. So, after one day you find 4 chocolates are completed. Second day, who is working? B. So, B will eat 3 chocolates a day. So, after 2 days we find 7 chocolates are completed. After 2 days 7 chocolates are completed. And we already know that the work done for every 2 days will be same. That is, after every 2 days the chocolates completed should be multiples of 7. Now, what is the nearest multiple of 7 less than 60? The nearest multiple of 7 less than 60 is 56. They complete 7 chocolates in 2 days. Then to complete 56 chocolates, how many days do they take? 7 8s are 56, 2 8s are 16. So, after 16 days, you see that 56 chocolates are completed. Now, who is working on this 16th day? Now, A is working on odd days and B is working on even days. So, on this 16th day, B should be working. Now, the next remaining work should be done by A because the next day is 17th day work which should be done by A. And the remaining chocolates are 4. Now, A in a day will eat 4 chocolates and the remaining chocolates are also 4. So, definitely to complete that 4 chocolates, A will take 1 day. So, the total number of days to complete the work is 16 plus 1, 17 days. Now, this is the best way to answer this question. Now, let us discuss the next type of question in this chapter. Four men and 6 women working together can complete a work in 8 days, while 3 men and 7 women working together can complete the same work in 10 days. Now, the question is, in how many days will 2 men and 3 women working together can complete the same work? Now, here in this particular problem, we have men, women and days. Now, generally if you solve this problem, it becomes very lengthy. Then how to solve this problem in a very simple way? Now, first of all, let us discuss what is given in the question. 4 men and 6 women working together can complete the work in 8 days. 3 men and 7 women working together can complete the work in 10 days. Now the question is, in how many days will 2 men and 3 women working together can complete the same work? Now if you want to tell the answer for this question in a very simple way, we need to find out the efficiency of man and woman. Now how to find out the efficiency of man and woman? If we need to find out the efficiency of man and woman, make time equal. If we make time equal, we will get the efficiency of man and woman. Now let us see how to make it. Now in the question it is given 4 men and 6 women working together can complete the work in 8 days. Now if the work has to be completed in 1 day, then how many men and women are required? 4 men and 6 women will complete the work in 8 days, and if you want the work to be completed in 1 day, we require 8 times the people present there. That is, to complete the work in 1 day, we require 32 men and 48 women. 8 into 4 32, 8 into 6 48. Now in the second case, we are given 3 men and 7 women working together can complete the work in 10 days. Now if you want to complete the work in 1 day, how many men and women are required? We require 10 times the people present here. Now 10 times. So we require 30 men and 70 women to complete the same work in 1 day. Now 32 men and 48 women can complete the work in 1 day. 30 men and 70 women also can complete the same work in 1 day. So I can say the efficiency of 32 men and 48 women is same as the efficiency of 30 men and 70 women together. So with respect to efficiency, they are equal. Now solving this, I get 2 men is equal to, that is 32 minus 30, 2 men is equal to 70 minus 48, 22 women, or 1 man is equal to 11 women. So a man is 11 times efficient than a woman. It means if I take in a very simple way, and if I want to solve this problem in a very simple way, I start like this. If suppose I say a woman eats 1 chocolate a day, definitely the man should eat 11 chocolates a day. Using this simple point, now let us solve this problem. Now here, to complete the work in 8 days, we require 4 men and 6 women. We know that a woman will eat only 1 chocolate a day. So 6 women will be eating 6 chocolates a day, and a man will be eating 11 chocolates a day. So 4 men should be eating 44 chocolates a day. So the total work will be 4 into 11, that is 44 chocolates, plus 6 into 1, that is 6 chocolates. Now these are the chocolates eaten by 4 men and 6 women in 1 day, and the total work will be completed in 8 days. So your total work will be 44 plus 6, 50 into 8, 400. Now this 400 works should be now completed by 2 men and 3 women. Now 2 men in a day will eat 2 into 11, 22 chocolates, and 3 women in a day will eat 3 into 1, 3 chocolates. Now 2 men and 3 women in a day will be eating 22 plus 3, 25 chocolates. Then to eat 400 chocolates, how many days will they take? Answer is 400 by 25, which is 25 ones 25, 150, 25 6, 150, 16 days. So 2 men and 3 women working together will complete the work in 16 days. Now let us go to the next problem in this chapter. A and B together undertook to do a piece of work for rupees 54,000. A can complete the work in 12 days and B can complete the same work in 18 days. If they complete the work with the help of C in 6 days, then how much money is paid to C? Now, this is a problem related to wages. Now, how is the money distributed among the persons doing work? Generally, many people think that it depends upon efficiency. To be frank, it depends upon efficiency only when time is equal. But if time is not equal, then it does not depend upon efficiency. Directly you can assume money is depend upon work done. That is, the work you do, the money you take. How much work you do, that much money is paid to you. Now, if you analyze this problem carefully, A alone can complete the work in 12 days. B alone can complete the work in 18 days. But with the help of C, the work is completed in 6 days. So, if we can find out how much work did C do in that 6 days, we can tell how much money is paid to C. Now, let us try to solve the problem. Very simple. Alone, A can complete in 12 days, B can complete in 18 days. But with the help of C, work is completed in 6 days. That is, A should be working for 6 days, B should be working for 6 days and C also should be working for 6 days. Now, we can find out how much work did A do in that 6 days, B in that 6 days. Definitely, the remaining work is done by C. Now, A can complete the work in 12 days. His 1 day work should be 1 by 12 and A, B and C together completed the work in 6 days. That is, A is working for 6 days and in that 6 days he will be doing half of the work. So, if A has done half of the work, half of the money is paid to A. Now, B can complete the work in 18 days. His 1 day work should be 1 by 18 and 6 days work should be 6 by 18, which is 1/3. So, B should be paid 1/3 of the money. Then how much is paid to C? A and B together they completed half plus 1/3, which is 5 by 6 of the work. So, in the total work A and B did 5 by 6 of the work. So, how much work did C do? Definitely C might have done 1/6 of the work in 6 days. Now, I can even tell the answer how many days will C alone take to complete the work. If C is doing 1/6 of the work in 6 days, to complete the total work he should be taking 36 days. But that is not the question. The question is how much money is paid to C. Definitely, if C is doing 1/6 of the work, the amount paid to C should also be 1/6 of the total money. So, how much money is paid to C? Is 1/6 of 54,000. So, the money paid to C should be 9,000 rupees. Thank you for watching. For more videos, subscribe at Naresh IT.